Math 2, Unit 13, Section 2 continued. This is the volume of pyramids and cones. So it's the second part out of 3 in Section 2. We're talking about pyramids. In the previous part, we talked about prisms. Prisms have two bases that are parallel to each other. So if I'm talking about this cube right here, then the base on bottom has a parallel side. So this side on the bottom is parallel to the side on the top. And I can rotate that for you so you can see what it looks like. A pyramid just has one base. So a pyramid has the same base as this base, but only one of them, because it comes to a point at the top, and we call that point the vertex. Now, these two volumes are going to have a relationship between each other. Clearly, the volume of the pyramid is going to be smaller than the volume of the prism, because I can actually fit this one inside of the other one. But their base sizes, if you match them up, are actually the same size. So these are both square prism. It's a square prism, which is actually a cube in this case, and a square pyramid. It's named by its base because the base is a square, but it is a pyramid because it comes to a point or a vertex at the top. So I can actually fill up my pyramid with water, even this one's able to be filled with water, and pour it into this cube, and it should fill up 3 times. So we have little lines on here, and we just marked off where it fills up to. So the first time you fill it up, it goes 1/3 of the way, and then another third, and then it takes 3 of these to fill up, of these pyramids to fill up the prism. So you can just find the volume by taking the area of the base times the height, just like you did with a prism, but then we're going to divide it by 3 to get the volume of the pyramid. So just like on the previous side, we're going to find the area of the base first. In this case, my base is a rectangle, and I'm going to show that this is my base right here. So I'm doing length times width, which is 9 times 11, and that gives me 99 inches squared for the area of my base, or capital B. My h is my height of the pyramid. That must be measured perpendicular down to the center of your pyramid. Has to be in the center. It cannot be along this edge. So see how this line is drawn along the edge of this pyramid? That is not the height. We call that the slant height, and we can solve for the regular height if we know the slant height. But this pyramid, I can't take this bottom piece off. So in order to find that height inside, I can't put a ruler inside there. So we need another way of measuring it, and you can actually measure the slant height and measure the bottom of this to figure out what the height is inside. So in this case, we're already given the height on the inside. You just have to check if it's perpendicular on the inside, then that makes it the height of this pyramid. So we're going to use that as our h value. So when I take the volume formula, I do 1/3 the area of the base times the height of the prism. We already know the area of the base, which we calculated on the left, is 99. And now we plug in the height of the prism, which is 16. Well, 1/3 of 99 is 33. And then you can multiply that by 16, or you can multiply these two numbers together and divide by 3 at the very end. Either way, you should get 528 inches, and we're talking about volume, so that's cubed, inches cubed. For number 2, our base is also a rectangle, so I'm going to leave that one for you to solve on your own. You solve it just like the one before. Number 3, you're given a slant height. This is where I'm going to show you how to find your actual height of your pyramid if it's not given to you. So right now, I'm not given the perpendicular line that goes to the center of my base. I need to figure out what that is. Well, this shape is actually a triangle. So you need to remember, if I pull that triangle out to the side here, I'm trying to find the part that's perpendicular, so I want to know this height here. And I know that the slant height is 25, so this diagonal line will be 25. How much is this bottom piece? It's not all the way across. It has to be in the middle of the base, so halfway across there would be half of 30, which is 15. If you know two sides of a triangle, how do you solve for the third? Hopefully you said Pythagorean theorem. So we're going to do 15 squared plus x squared gives me 25 squared. And then solve in order to know that height. So 15 squared is 225. 25 squared is 625. And solving for x, I would subtract the 225 from each side. And I get 400. If x squared equals 400, how do I solve for x? Hopefully you said take the square root. I take the square root of each side here. Square root of 400 is 20. We're talking about the principal square root. This is a distance, so I don't need negative 20. My distance will never be negative. So this height is 20 feet high. So that's 20. And we're going to use that later. We use that in the volume formula. Once we plug in our height, it will be 20. But before I can do that, I need to solve for the area of the base. Well, this base is also a rectangle. Actually, more specifically, the base and the height here, or the length and the width, are the same, so it's a square. So 30 times 30, or 30 squared, gives me the area of my base, which is 900. I'm going to plug that into my volume formula in order to solve. So you can multiply 900 times 20 and divide by 3, or 1/3 of 900 is 300. Then multiply by 20. You should get 6,000 feet cubed as your answer. All right, moving down to number 4. Number 4 is a triangular prism. These other ones were rectangular prisms, and this was a square prism. The base here is a triangle, so when I find the area of the base, I need to make sure I'm finding the area of that triangle. Well, the area of a triangle is 1/2 the base times the height. The base and the height must be perpendicular to each other, so 12 is perpendicular to 7. So 12 and 7 are my base and my height of my triangular base. I do not want to use the height of the pyramid when I'm solving for the area of the base. I'm just talking about the shaded triangle when I'm solving for area of the base. And that will give you 42. And then when you're talking about volume, we're doing 1/3 of the area of the base, which is 42, times the height. And the height is the distance between the base and the vertex, which is 10. So again, these are two different types of heights. One is the height of my pyramid, which is between the base and the vertex. The other one is the height of the triangle, which is the perpendicular height to the base. All right, when you multiply all of that together and divide by 3, you get 140 millimeters cubed. Moving on to number 5, you're going to solve this one the same way. Just make sure when you're finding the area of the triangle, you're looking for the base and the height that are perpendicular to each other. The base is 5. The base is 5 right here. The height has to be perpendicular, so you need to know this side right here. If you don't know that side there, then you need to use Pythagorean theorem to find it, because this is a right triangle. So you would do 5 squared plus x squared gives you your hypotenuse, which is 13 squared. So solving for that next side, you can find that value there, and you're using base equals 1/2 of 5 times whatever height you solve for your triangle, so that x value, and keep solving from there. I'm going to go ahead and solve that one out so that you know how to do it. So that's 25 x squared equals 169. When you subtract 25 from each side, you should get 144, which means when you take the square root, x equals 12. So you plug in a 12 for the height of your triangle, and you get 30. So 5 times 12 divided by 2 is 30. Then you can plug that in for your volume, and then multiply by the height of the pyramid, which is the distance between the center of the base and the vertex. 19. Plug those in and you get 190 meters cubed. Okay, flipping over to the back side. The application for cones is very similar. The only difference is we're using pi r squared instead of the area of the base, which pi r squared is the area of this base, which is a circle. So it's the same thing. So we need to find our radius. So that's my first variable I plug in. My radius here from the center to the outside of the circle is 9. And the height of the cone is 17. And remember, your height needs to go from the center of your circle to your vertex of your cone, which is the point or the tip of the party hat. You're multiplying these numbers together. You're going to do 1/3. 9 squared happens first because exponents in order of operations happens first. You're going to leave your answer in terms of pi, so just multiply 81 times 17 and divide by 3. And you should get 459 pi yards cubed, because we're talking about volume. Okay, for number 8, you'll solve very similar, but remember, it gives you the diameter, so your radius would be half of the diameter, and your radius would be 6. For number 9, we're going to do this one together. You'll do 8 on your own. Volume equals 1/3 pi, the radius squared times the height. Well, my radius is half of this diameter, so my radius is 12. But the height is going to be from the vertex to the center of your base. We don't know this right here, so I'm going to draw a triangle on the side. We do know the length from the center to the outside is my radius, so that is 12. And we know the 13 is the hypotenuse. So you can do Pythagorean theorem. We did the same Pythagorean theorem on this side. If we have 13 and we solved and got 12, these are called Pythagorean triples. A 5, 12, 13 is a Pythagorean triple. And so if you have two of these numbers, then the third one will also be your answer. So if we have 13 and 12, my missing side is 5. So that will be your height here. But remember, you can always do 12 squared, which is this base, plus x squared equals 13 squared, and you solve for x and you should get 5. Plugging those in, we're going to do 12 squared first. 12 times 12 is 144. We're going to multiply that by 5 and then divide by 3. We get 240 pi kilometers cubed. The application section is very important because you will have a performance task that will be similar to something like the applications. So a cone has a volume of 1,309 cubic centimeters. If the height of the cone is 8 centimeters, find its radius. So let's draw the cone, because usually it gives us a picture, but this one did not. So the height of the cone is 8 centimeters. Find its radius. So I know that volume equals 1/3 pi times the radius squared times the height. Our volume that we have is 1,309. We don't know the radius, but we do know the height is 8. Okay, so I'm going to start solving for my radius. Well, if I solve for my radius, then I need to get r squared by itself, which means first, to get rid of my fraction, I can multiply by 3 on each side. That gives me 3,927 equals pi r squared times 8. And I'm going to write my 8 out in front, 8 pi r squared. We want r by itself, so we need to get rid of everything that's not r. Both of these things are being multiplied to r, so I'm going to divide by 8 pi on each side. So r squared is equal to 3,927 divided by 8. So you can divide by 8, and then you also want to divide by pi. And you get approximately 156.25. Approximately 156.25. But that's r squared, so to solve for the radius, we'd have to take the square root of that number. So the square root of 156.25 equals 12.5 as my radius. So remember, on these application problems, you're actually going to use the pi button when you're dividing. So what I did on this piece here is I put 3,927. You're going to divide, and you can put your 8 pi in parentheses because you're dividing by both of them. So 8 pi. Or you can divide them separately, but you would have to divide one at a time. So if I want to divide both of those at the same time, make sure you put it in parentheses. And that's where this 156.25 comes from. We'll round to 2 decimal places, and then we take the square root of that number, square root of 156.25, and you get, sorry, that was the answer times that. I pushed the wrong button. Square root of 156.25 is 12.5. Next problem. Caitlin must build a sandcastle in the form of a square pyramid we're actually going to talk about, you're going to solve this one on your own. I'm going to help you set it up a little bit. She bought 3 bags of sand, each containing 1,200 inches cubed of sand. Will she have enough? Well, here's the sandcastle on the left. You need to find the volume of this. She has 3 bags, so she has 3,600 cubic inches of sand. Is this volume more than or less than 3,600 cubic inches? You're going to find that out on your own. Then the second, number 11, should be number 12. The cylinder to the left contains 2 congruent hollow cones. So it's like you drilled a cone on this side and from the other side, but the rest of the figure is solid. If the cylinder has a height of 20 inches and its diameter is 14 inches, find the volume of the solid. The cones have been drilled out, the rest of it stays. So we're going to find the height or the volume of each cone. There are 2 cones. They kind of look like this hourglass shape. And we're going to subtract that from the volume of the cylinder. So let's first find the height of each cone. So the height of each of them is going to be the same because they're congruent cones. I'm sorry, the volume of each of them is the same because they're congruent cones, but the height of the cylinder is 20 inches, which means the height of each cone is 10 inches. The diameter is 14 inches, which means the radius is 7. So if I find the volume of one of these cones, I'll double it to get the volume of both. So 1/3 pi times my radius, which is 7 squared, times the height, which is 10. So 7 times 7 is 49. 49 times 10 is 490. So we're going to do 490 divided by 3, or 49 times 10 divided by 3, same thing. And you get 1.63, but we still need to multiply that by pi, and remember the pi button is on your calculator. So you get approximately 513.13. And remember, that's the volume of one cone, so to get the volume of 2 cones, we're going to multiply that by 2. And we get 1,026.26. This is 2.5, but we rounded this one, so I'm just going to use the one we rounded. That's the volume of 2 cones, but that's the part that's been drilled out of the cylinder. So we need to find the volume of the cylinder next, which is area of the base times the height, or pi r squared times the height. My radius is the same as the radius of the cone because they're the same size. So that's 7 squared. But the height of the cylinder is the entire height, which is 20. So 49, or 7 times 7 is 49, times 20. And then we're going to multiply that by pi. And we get approximately 3,078.76. This is the area of the solid. We want to subtract 1,026.26 from that. And our answer is 2,052.5 inches cubed because it is volume of a solid. Go back and solve each problem that we skipped. So those are the ones that you do on your own. and then we'll move on to the last piece of section